joining, and thank you to the PaLM coaches for giving us this presentation of what's new is in IHE-PaLM domain. First, a quick reminder, maybe if you can go to the next slide, about the upcoming Connectathon that will take place in Trieste in Italy, the first week of June. So the registration is still open. And next slide, so that's this year it's a three-step process. Let's say that there's two main steps. You first need to complete an administrative registration using ClickUp. It will create your contract, and you will receive your invoice afterwards. And then you can register your system in Gazelle. That task you can conduct in parallel, because the soonest you have your system in Gazelle, the soonest we know which profiles you want to test, and we can start recruiting more participants. So today we have something like 50 to 60 systems registered. Not all yet in Gazelle, but we already have a good number of participants. So registration officially closed at the end of this week. I guess we will be able to extend a little bit if you need to. So do not hesitate to visit the IHE-Europe website to get details about the process. So thank you. I don't know who speak first, but the floor is all yours.
Okay. Yeah, so this is Riki Merrick. I'm the IHE PaLM planning co-chair, and together with Dr. Dash and Alessandro, we're going to tell you what we're doing in the pathology and laboratory medicine, or PaLM domain. So typical agenda, we're going to give you a brief overview of the PaLM domain. That's my job, and then talk about the current work and the profiles for the June Connectathon, and we'll have some time at the end for question and answers. Why do you use IHE? And hopefully you already know because you're attending, but IHE writes specification that takes existing standards and looks at a specific use case and adopts the standards for that use case. It writes the integration profile, and then puts the test cases into the testing software, what Engel just talked about. It's called Gazelle. And then you can test independently, and you can test at Connectathons, and then hopefully systems are much better set up to connect to other systems in the real world as well. So there are several domains in an IHE, and the pathology and laboratory medicine domain is the one we're going to talk about. It used to be called lab and anatomic pathology, and we merged those two together. So what is in our domain space? It's the exchange of digital assets associated with services performed on specimens by both clinical and anatomical pathology laboratories. It includes analytical and peri-analytical automation, the representation and exchange of structured data related to specimen management, for example, biobanks. It includes secondary use of laboratory observations and related clinical observations, and it's also touching transfusion medicine. So pretty broad scope. So these are all the different types of IT systems in the PaLM domain space. And so here are the specific profiles. So we have the external workflow profiles that deal with laboratory testing workflow, and anything that's marked with an F is in final text, and T is trial implementation, and D is under development. So the laboratory testing workflow is the exchange of lab orders and results between two laboratories. So for reference testing, LBL is for labeling, LPOCT is for point of care testing devices, and then LCC is the laboratory clinical communication. That's for things when you want to make changes to an order. Currently, I think most people do that by picking up the phone, but this describes how you can do that electronically much better. For external reporting, which includes the secondary use of data, we have reporting of lab results via XT-Lab in the final text, and then as trial use profiles, the reporting to public health, which I'm not sure how much implementation we've seen. And then we have the anatomic pathology structure report, which is based on XT-Lab, also using CDA. And there's some implementation, I believe, going on in Europe, where XT-Lab also is quite implemented. And then we have subcontracting in the interlaboratory workflow. So the LTW, sorry, was the testing workflow within the hospital instead. Then we have a suite of different domains that we're aiming for. So the first suite we're talking about is transfusion medicine, and there we have the adverse event reporting profiles as a trial profile available. And we'll be working on more. We have internal automation, specifically laboratory device automation in final text. And then we have laboratory analytical workflow. So that's the IVD test instrument to the laboratory analytic manager. So that's all the workflow steps for that. It's also in final text. And the laboratory specimen handling is in development. And then last but not least, we have the DPIA in trial implementation. We're working on DPIO, and the next one is the evidence creation profile we're also working on at the moment. And I think I forgot one that's in development that would probably fit under the external workflows. That's proficiency testing. We're just starting to pull that together. And then we have some services that go between all the stakeholders. So one is the LCSD. So that's the laboratory catalog exchange, where the laboratory, or a specimen collection manual, where the laboratory lists all the tests that they have to offer, including all the details around what results will be coming back for those tests, so that receiving system can be set up for electronic data exchange, and the specimen event tracking trial implementation specification that ensures that you can always know where in the workflow process your specimen is and what the next step for it might be. And with that, I think I'll hand it over to Alessandro.
Yes, just to talk about the new version of the technical framework for the PaLM domain. We are going to release the revision 11, and we plan to be able to release it in the next month, and includes several change proposals for several profiles. And the most important changes are for low profile. We have some important CPs, and we talk about them later. Another important change for this revision is that for the volume 2, the one that involves all the transactions related to all the profiles have been merged and collected back to in a unique volume. So you will find in the revision 11 a unique volume 2 listing all the transactions for all profiles. Instead, until the revision 10, this volume was merged into 3 separate volumes, 2A, 2B, and 2C, that have been merged in this revision 11. Now we will go to talk about the concurrent work and what we have new from the point of view of new profiles. And so I think that Raj will talk about that.
Thank you, Alessandro and Riki. This is Raj Dash. I'm a pathologist at Duke Health and a clinical informaticist, and I've been very excited to work with IHE PaLM and DICOM Working Group 26 for the development of the digital pathology suite of profiles, the first of which I'll talk about just shortly. DICOM has been instrumental in helping us and collaborating with us to ensure that the protocols are in support of the DICOM standard. DICOM Supplement 222 is the most recent release for pathology that focuses on digital annotations. And so there's been close collaboration to recognize how these standards can best be leveraged to support the use cases in the PaLM integration profiles. There are many elements of DICOM that are not fully utilized in the pathology and laboratory domain. We're hoping to be able to make better use of them, fully populate the metadata, and realize the power of the underlying standard. Of course, there are always gaps, and part of our effort is also to identify where those gaps exist in support of the IHE digital pathology use cases and address those. And one example is given there of lack of discrete coding for immunohistochemistry, so challenging to understand what is the whole slide image that's being interpreted from a machine understanding standpoint. At least we still, in today's day and age, have to have a human looking at the label on the glass slide to understand how to interpret that slide. Next slide. Okay, so let me start with how can anyone contribute, and one is to take a look at this link and evaluate the use cases. If there's missing use cases, to indicate that there's a high prevalence need in the market that's not currently being met. And of course, we have a number of profiles in development, which I will step through in more detail, and having your input is critical. I'll give acknowledgement for the DPIA profile. We had significant input from Philips, Leica, and Roche, and input from a couple of LIS vendors in the USA and in Europe. And that was instrumental to ensure that we had a profile that was truly functional in supporting the use cases. So please consider having your product in a connectathon with other leading digital pathology vendors. We have a monthly 1 to 2 hour teleconference where we review the documents, go over the profiles, try to make progress, and plan for connectathons. Next slide. So this looks a little bit busy, but let me just try to explain. On the far left, it's actually not labeled, but we have an order placer that's essentially the EHR. And so in IHE, we use all of these roles rather than specific software. But generally speaking, in today's market, the order placer represents the electronic health record. The order filler in this circumstance is generally the laboratory information system. And then in order to acquire a whole slide image from a digital scanner, a request is made to the acquisition manager, which is the software that runs the scanner. Then the acquisition modality is the actual whole slide imaging scanner in most circumstances. which creates a digital image and then has to store it somewhere, which would be in a PAC system, which is here is described as the Image Manager Archive. We have a role here for something that creates new evidence, different than the scanner that works on a whole site image, and I'll talk about that in a little bit more detail. And of course, we need to be able to see these images, so we have an image display actor. And I think next slide. So these are how all the different profiles were envisioned to cover the different spectrum of transactions that need to occur between these actors communicating with one another. The first is the Digital Pathology Image Acquisition Profile, or DPIA, which I'll go into in more detail next. Our focus in the beginning was to create the simplest profile possible to cover the acquisition of a whole slide image. Then some of the other profiles include communication between the other actors that might be necessary. So after you've created the whole slide image, how do you communicate between the image management software and the scanner? That's DPIO, and or now that's being expanded to also incorporate communication between the order filler, the LIS, and the Image Manager Archive. So when the PACS needs to talk to the LIS, DPIO will probably end up managing that as well. The DPOR is for the order placement and results. That is something that will probably leverage transactions that already exist. Orders, of course, are placed from the EHR to the pathology lab information system today already. Transactions are well established, and so that is really just a placeholder if there's elements missing in the functionality and support of digital pathology workflows versus traditional workflows, electronic workflows today. And then, of course, the evidence creation mentioned just now is creation of new evidence based on a whole slide image, and I'll talk about some of the use cases there. Next slide. Okay, so here's the scope of the profiles. So DPIA, as mentioned, is all about the creation of that whole slide image DICOM file. DPIO is focused on supporting communication in support of the workflow to manage that whole slide image after it's been created. Evidence creation is focused on the analysis of a whole slide image. And then the DPOR is something that we'll take a look at probably at the end to fill in any gaps that exist between the EHR and LIS in support of digital pathology workflows. Next slide. So image acquisition is the first one. We'll do a little bit of a deep dive. So whole slide image acquisition, this is really paralleling the laboratory analytic workflow in the clinical lab. And it's has support for additional metadata that needs to populate the DICOM data file and to handle the typical types of information and processes needed in the acquisition of a whole slide image, such as instructions on magnification, the type of stains, the slide material, that kind of thing. So we'll see that the general workflow is, a typical pathology order results in an order being placed in the EHR, going to the LIS, then a request for a whole slide image, going to the image management software. A number of steps involved, smaller steps to acquire the whole slide image, storing the image into the PACS, recognizing that there's an image available and notifying back to the acquisition manager, which then needs to let the LIS know that images are available. And then whenever there's an image to display, bringing it back out of the Image Manager Archive and actually displaying it. Okay, next slide. All right, so this, as mentioned, is the laboratory analytic workflow's cousin for pathology, built in close collaboration with DICOM. So this is strictly around a simple model for acquisition of a digital image from usually a glass slide, but it could potentially be also used for a gross specimen, which is one of the use cases, but our focus really has been on whole slide imaging. These are the transactions where the software can work in two different ways to interact with the scanner. It's always possible that the scanner receives a slide without any information other than the slide barcode, in which case it might query the acquisition manager for information. Alternatively, an acquisition manager can broadcast to one or more scanners the acquisition modalities via the broadcast call with all the information necessary to populate the DICOM metadata for creation of a new whole slide image. And then we have a status change Lab82 message based on the actual events that are occurring. The acquisition modality interacts with the image manager archive using established radiology transactions to store the images, and then established radiology transactions to display the image from the PACS system. Okay, and that has been published in trial implementation. Next slide. So, as mentioned, we originally focused on the simplest approach for whole slide image acquisition, really pared it down to those data elements in the transaction that would be the bare minimum required in order to get this up and running. What it does not currently address is how to obtain additional metadata to populate the DICOM whole slide imaging file. And one of the elements that was missing from the initial set of data elements was, for example, the stain, and how to model, what is the actual stain that's being looked at right now. Almost everyone, whether you're in the Europe, Asia, or the United States, is actually has a human looking at the label to understand what stain, similar to what happens with glass slides. So there's obviously some benefits to having some machine understanding of what the digital image actually represents, and that's one of the things we're working on a change proposal right now. Next slide. So here's kind of the minimum data elements that's been expanded slightly that we focused on. Some things are pretty straightforward. One of the ones that was a little bit more complicated, so I would say we left it for phase 2 and we're working on this change proposal now, is how best to represent the stain that's there. And of course, this can be somewhat complicated, as it's sometimes a routine hematoxylin and eosin stain, sometimes a special stain for microorganisms, other times immunohistochemical stain, and sometimes it's not just one antibody, but multiple antibodies that are applied in sequence in order to highlight various features of the tissue that was on the glass slide. And how to represent it and code it is something that DICOM supports through SNOMED CT, but one of the gaps, as mentioned, is that SNOMED CT does not have a coded representation of everything that might typically be found in a whole slide image for these special stains. Next slide. Okay, so one of the things that was necessary was recognizing that as the whole slide image is being created, there needs to be some communication between the software that's generating the whole slide image and the LIS to populate key metadata elements. And so we've been working these through on our calls, and we've come up with some proposals. We would welcome feedback as well as engagement to make sure that we are proposing in this change proposal something that will work for your software system if you're implementing digital pathology. And here's a preview of things to come. And just as an example, we've spent and gone back and forth on whether to use SPM6 or a pair of OBXs to recognize what the stain is. And I think we've settled on SPM6 as a repeatable field to be able to accommodate the multiple stains that might be present in a single whole slide image. So more to come on that. If you have software that's functioning in this arena, please join us. Next slide. Okay, so I'm going to quickly cover the other profiles that are a work in progress in addition to the change proposal for DPIA. So the use cases here for DPIO is communication between the LIS, the image management system, or that software that's running the scanner, and the PACS system, which is really interacting with the user. When there's a new digital asset, there needs to be a notification that that digital asset exists. Of course, the LIS is the manager of the physical assets, the glass slides, but in today's day and age, it's starting to become also the inventory management system for the digital asset along with the PACS. So there needs to be tight communication between those two systems. So one transaction is necessary to announce that there's a request for a new digital asset, and then the other one is to actually recognize that the asset has been created and is it available for display to the user. And there also needs to be communication, for things like the stain and other things. For example, if a PACS system wants to be able to display the prior pathology and serve as the front end for interaction with the user as they're looking at whole slide images, or they want to be able to resequence based on a block diagram of where the tissue came from, or correlate, perhaps the physical assets with the digital assets. All of these require additional communication about the whole slide image between the PACS and the LIS. So that's additional consideration for this DPIA profile that is under development. Next slide. Okay, so just a pictorial representation of what I just said. There's some established transactions, but I think we're going to have to modify them in order to have this communication. We are working closely with DICOM Working Group 26 to make sure that we're doing this in a way that's fully supportive of the underlying standard. Hopefully we'll have something available to show by the summer. Next slide. Okay, so evidence creation is a very exciting area, but we logically has followed these other profiles. And so I'm just going to list some of the use cases here. Of course, the promise of digital pathology is incorporation of machine learning and additional aids for the pathologist to make the pathologist better than he or she might be alone. And so doing things like rare event detection, finding very rare microorganisms that are tedious to find even on special stains for a human could be a simpler matter, and more reliably done using the machine. And so in order to support this, we plan to create this new digital pathology evidence creation profile. And this is going to create new data, and that data might be in the form of an annotation or a coordinate. So for example, if an acid-fast bacilli is found, it might put a square around it or an arrow pointing to it, or coordinates, and send that back to the PACS system and or to the LIS or order filler. And it might, that's just one example, but it might find many other aspects that are important for evaluation and send it back to the pathologist to review. The plan is to be able to send both quantitative and qualitative data. And you can see some of the examples there. Right now, with all of the image analysis algorithms in digital pathology, there is either a proprietary interface being created instead of a standard one, or there's manual copying and pasting. So, for example, at Duke Health, when we do our breast biomarkers, of which we do probably 20 a day, 20 different cases, all analyzed using FDA-approved algorithms. At the end of the day, the numbers that are produced, such as the percent staining, the intensity of the staining, are hand copied and pasted back from one system into another system. So clearly suboptimal, and there's definitely a need for bringing this all into a standard transaction. So there's many new and exciting possibilities with this that go beyond just quantitative and qualitative data, such as creating new whole slide images or complex data objects. Really, the sky's the limit with machine learning and the ability to integrate that with digital pathology. So very exciting. We'd like to accelerate this. There's a few folks on DICOM that represent the image analysis and AI machine learning space in digital pathology, but we haven't gained traction yet in this, and definitely looking for those that are interested in contributing to this space. Next slide. Okay, and now handing it back over to Alessandro to talk about the test cases.
Yes, okay. About DPIA, we have already discussed about how many test cases we could write in order to be able to vendors to test the profile with at the connectathon. So there's been a long discussion about the test case building for DPIA. And that's the list of the test cases that we currently have under construction. There's been already a first iteration of these test cases, so I think that they are almost ready to be included into Gazelle. For those of you that are not familiar with connectathon testing, mainly each profile has a number of tests that each vendor has to perform at the connectathon. Mainly these tests are peer-to-peer tests. It means that a vendor that plays a role A, for example, under a specific profile, will have as a partner another vendor that plays role B and demonstrates the compliance to the profile by playing one or more transactions. In the context of DPIA, we have several roles. Some of them are mainly roles of the laboratory part of the profile, we can say. So the acquisition of the slide between the interaction between the acquisition manager and the acquisition modality actors. And then we have a second part, which is mainly a radiology part that involves image manager, image archiver, image display. For this part, we have adopted in the profile some of the radiology transaction, for example, RAD8, RAD10, and so on. So these are the four test cases. Each test case has a description part of the tests, then then the description of all the specific steps of the transactions that vendors will have to perform, and then also an evaluation part. It's the part that it's dedicated to the monitors that are the experts responsible to validate the test. And so, according to these profiles, there are mainly the first two tests that address the two modalities that the profiles makes available to perform a slide acquisition between the acquisition manager and the modality, that are mainly broadcast and query mode. So we are testing these parts. The third and fourth, as I said, includes also the radiology transaction. So we are testing the digitalization itself and the saving of the storage, of the images in an archiver, for example. We won't go in detail of each one of these tests, but here you can find the links to the draft of each specific tests. So if you wanna inspect the test in detail, you can read it. This test, as I said, has been already approved by the committee, and now we are going to include them into Gazelle in order to make the vendors able to test the profile. So according to the number of vendors that we will have in the future connectathons, we will do also this part. As Lab 80, Lab 81, and Lab 82 involve HL7 version 2 as the underlying standard, there is a second part of the job for Gazelle testing of DPIA that involves the message profiling. So we have used the IGAM tool to build the profiles for all HL7 messages used in DPIA in a way that, starting from this profile, we will be able to generate all the specific HL7 version 2 validators for DPIA. That's because HL7 version 2 validator are crucial for each profiles, not only for DPIA, to ensure that the messages exchanged by the vendor at the connectaton are compliant to the profile itself. So starting from the output of this tool, we will be able to include in Gazelle also the profiling for the messages. And last but not least, another important aspects of testing and of evaluation of DPIA profiles at the connectaton are the DICOM mappings. So what does it mean? It means that as the first part of the profiles involves HL7 version 2 transactions, and the final part that involves image archives involves DICOM transactions, we have to be sure that the mapping between HL7 version 2 fields and DICOM fields is as more complete as we can. This is a work in progress because I think that we will have more mappings in the coming months as soon as the development of DPIA goes ahead. And at the moment, together with the working group 26, we have identified this first mapping that represents the minimum sets of fields and of attributes that are needed in order to ensure that also the DICOM transaction are performed in the right way. So with the help of DICOM working group 26, we have been able to build these mappings, and all the vendors that are coming to the connectaton to test DPIA should have it in mind in order to ensure that all the requirements from the DICOM point of view are satisfied, starting from the HL7 version 2 transaction for the HL7 version 2 actors, we can say. So now also a few words about two hot profiles, we can say, to the connectaton, and we have laboratory testing workflow first. And I think that it's one of the profile that has been tested more in the past connectaton, as it involves we can say the first part of the overall laboratory process. So the part involving the request of a laboratory order, starting, for example, from an hospital ward, we can say. Generally speaking, we can say an order placer actor to the order filler, which is the lab itself, and involves as use case and transaction lab 1 and lab 2 that are mainly related to the order request. If this request for a laboratory order starts from an hospital ward, for example, the order placer, or starts from the laboratory itself, the order filler. Then we have other two actors, which are the order results tracker and the automation manager, that are related to the performance of the laboratory test itself. It means once that the order filler has a laboratory order, he will send a work order management to the automation manager, which says, okay, I have to perform all these laboratory tests for this order. Then the automation manager in another profile will instantiate to the analyzer all these tests in order to perform the test and get the results. And these results management is handled by Lab 3 and Lab 5. Lab 5 back from the automation manager to the order filler, and Lab 3 to the order result checker, which is a specific actor that has the purpose to collect all the order results. So also for this profile, we have several test cases. These test cases, as they are in production, are already into Gazelle. So if you look inside Gazelle in the overall test list of Gazelle for the connectathon, under PaLM and under laboratory sensitive workflow profile, you will find this list of tests that are related to specific transaction to test, specific use cases to test. So according from the actors that a vendor is playing, he will have to perform one or more of these test instances. The second key profile, as I said, is the laboratory analytical workflow, which in relation to the previous diagram of the laboratory testing workflow involves the part where the analyzer manager is, we can say, the collector between laboratory testing workflow and this profile, because here we are addressing the use cases where an analyzer manager has already received from the lab the list of tests to perform for an order, and he splits the order in a series of analytical work order steps, which are some atomic parts of the order, atomic tests, we can say, that will be performed by the analyzer actor in one or more analyzer. And the way analyzer manager and analyzer communicates is different according to the modality of transmission of these analytical work order steps. We can have a query for a work order step made by the analyzer to the analyzer manager. For example, when the analyzer receives the specimen and queries to the analyzer manager about how many tests I have to do for this specimen. Another modality is the broadcast mode, where it's the analyzer manager that broadcasts a specific request of some work order steps to perform to the analyzer, and then it will be one of the analyzer, if available, that will taking care the work order steps and perform the test in a specific specimen. There are also various scenarios according to the fact that the specimen has been already received by the analyzer or not. Also to address some rerun of some tests, so also some reflect tests. And this specific profile is one of the profiles mainly involved in the last changes of revision of new technical framework revision 1, as I said before. We will see it in a moment. Just also for this profile, a list of all connectathon test cases that we have. Also, these test cases are in production because the profile this profile has already been tested in some of the past connectathon. Sorry, if I'm not wrong, in RENS some years ago we tested this one with 2 vendors, I think, and also in this case we have some tests that a specific vendor we will have to perform according to its role, and they are addressing some involved HL7 version 2 transaction according to test all the particular modalities of transmission of the analytical work order step information, rerun, reflex tests, and so on. As I said, there have been some important updates to these profiles that will be included in the revision 11. And the most important are to have the possibility to send additional result identifier like link codes between the transactions, and also the possibility to make a query for analytical work on the step by both sample identifier of the specimen and its carrier position in the rack. That is something that vendors asked to add, and we will add it in the revision 11, and then fix some ambiguity about the usage of OBX2 in the HL7 version 2 message. One important thing is that this update has been also acknowledged by CLSI Auto 16 standard, and it will be updated accordingly after the PaLM revision 11 release. So laboratory analytical workflow and CLSI Auto 16 are in some way working and developing together, and this is a very important aspect. The fact that these two standards are integrated and also receive the changes the one from the other, we can say. So Riki, I think that I can give you back the floor to you for the conclusions.
Riki, you're muted.
Yes, sorry about that. So if you want to contribute, join IHE if you haven't already. Join PaLM. As Dr. Dash said, we meet once a month for 1 or 2 hours, depending on how much work we have scheduled for ourselves. And then we do appreciate domain expert input. So for some specific, I mean, we always appreciate anybody's input and comments during the supplement public comment period. Obviously, we appreciate everybody testing our profiles at Connectathon, and if you have specific domain expertise and comments that you can help us with, for example, on the DICOM side with the members of the DICOM Working Group 26, we obviously take any help we can get that way as well. And that brings us to the conclusion. I've got this slide of alphabet soup here in the end. In case any of the abbreviations weren't clear, you could look that up. And here are a couple other links to IHE in general. And I'll open it up for questions.
Yes, thank you very much. We have a question from Stephen.
Yep, just a question about DPIA. How are annotations handled in that profile? For
So
the go ahead,
DPIA, yeah, sure. DPIA doesn't handle annotations specifically per se at all. It's only focused on the acquisition of a whole slide image. So that profile, annotations are out of scope. So annotations really will be the focus of the evidence creation profile. So that's dealing, once you have the whole slide image, what you do with it, and the annotations that are attached to it would all be part of that profile.
Got it. Thank you.
Yeah.
And so if you're interested in that, we haven't started work on it, join us.
Very good. Thank you.
Other questions?
I have a question regarding DPIA. That's a practical question for testing at the connector zone, maybe. What would be the gap for radiology system? I mean, PACS and image display to implement those, the DPIA profile. Is that something that is very similar to the what is done in radiology? It's only a matter of code, maybe, or?
Yeah, so I'll let Alessandro comment in a moment, but you know, the actors involved represent the scanner, the software that runs the scanner, and then the PAC system, which usually also function as a display actor as well as the image manager, archive manager. So it would be, you know, for testing, it's really between a scanner vendor and a PAC system for those transactions.
Well, but for the display, I think it's between the analyzer manager and the PACs. So the display test cases, which we pulled out that only use the RAD transactions, I don't think we made any changes to those transactions. We adopted them as they are. So for the image display, that should be no difference.
Okay, so if we want to drive the testing of DPIA, we can try to find a few radiology vendors that would be okay to test DPIA as PACS or image display, and it would be roughly at no cost for them. I mean, no development cost.
Yes, I think
if
that
we want a starting point.
If this vendor play RAD 10, RAD 8, RAN 107 or 1229 in the context of radiology in some other profile, they will also to be able automatically to play also the DPIA profile, because as Riki said, we haven't made the change to the radiology transaction, but we take them as it is. Obviously, it's important the mapping between HL7 version 2 messages and the DICOM metadata, in order to ensure that we are providing all metadata that are needed for to storage and for retrieve after also.
Yes.
I think one of the challenges is radiology systems today don't support the DICOM pathology standards. Sectra does, and they're one of the vendors that are working with us.
Okay. Thank you.
Any other questions in the last 2 minutes?
If not, thank you very much. So we will share the slides through Zoho. I will also publish the link on Gazelle homepage. And as soon as the recording is ready, we will publish it as well. Thank you very much to all the participants. Thank you very much to the co-chairs for this very good presentation. And yes,
Thank
I
you
hope